So let's start. Oops. Yeah. So that's me. And probably if you've been on a Max presentation here like 1 hour ago, he showed a slide with the 8 faces on it. And actually one of the faces was mine. So my name is Igor, and I work in a community engineering team. I've been with Magento for 6 years, and I made a lot of useful stuff for the Magento in general. And one of the stuff is the API development. So today we will talk about the API development, what we recommend, how we recommend to design your own APIs, how we recommend to use the Magento APIs which already delivered with the Magento. Because from our perspective, the API is one of the most crucial part of the architecture development. So yeah, API. And when we're talking about the API, actually, we should consider API as a set of the building blocks which we use for the building application and especially for the integration application. Because most of you here using the Magento actually rely on Magento API. Because actually such a big system as Magento, which is pretty robust, and actually it implies the kind of integration with a different external system, with the ERP system, with the product management system, with other plugins and extensions written by extension developers. That's why actually our API should be extensible enough, should be laconic, and what also is very important here, that we should not break our API too often, because that will lead to making changes to all of you who rely on that API. So the API should be also forward compatible, and actually that makes sense for the merchant, because merchants are really interested in the cost efficiency of their code, and not to make a lot of changes to proceed with any further patch upgrade of the system. So the API is bad, or is it good? And sometimes it's really hard to say whether it's bad or good. Because, for example, here it's a typical example of the API, because we have one system which will somehow operate and work with another system. And seeing this picture, probably your first impression is that these APIs are not so good enough. And probably you can make that assumption because, usually you're ready to see on the rails maybe tram or maybe train. So it would not be compatible with that kind of API which the guys with the guys firefighters put on the rails. But sometimes you are not ready to see. So actually, when you release the API, you see that developers and the company who start to use your APIs actually use it another way you initially thought about. And actually, that's the idea that API should be evolving. And it should not be, so you can't, at the design stage, predict all the possibilities how the API would be used. So you should be flexible enough. And actually, as a business, should be flexible enough. Your code should be flexible and provide all the possibilities for the business to evolve. And actually, that's why in Magento 2, we decided to introduce the thing which we internally call the service layer, and also we call it service interfaces. And actually, this kind of a set of facades over our business logic, and you can find this service layer in most of our modules inside of Magento. And these modules this service layer, this set of interfaces, supposed to provide an easy to use and understand the business logic provided by some particular module, or if you are talking about, if you are talking in terms of the domain-driven design of the bounded context. So each bounded context provides own set of APIs, and for example, if you would like to make some kind of integration with Magento or just utilize some of the possibility which Magento provides out of the box, you're supposed to go to this API and see what actually the business value provided by some particular module. So here actually it's a typical example of the API Magento provides. So these APIs are provided, so these particular APIs are taken from the MSI project, so this is gonna be new inventory API. And actually so you come to some module and you see the API folder. So under the API namespace, all our service layer interfaces are located. And you see actually just the two nested levels. So under the data namespace, we usually have the data transfer objects. And these objects supposed to be as simple as possible. So actually they are data transfer objects, and based on the description of data transfer, they should be out of the business logic, just the containers of data. And we have services on the top level. And the services actually manipulate with these data objects. So particularly, because actually Magento 2 is always evolving, and we already see some examples when our partners, when developers start to launch Magento 2 for big merchants, and they decided to go towards the microservice architecture. So actually, these kind of interfaces supposed to support the microservice architecture. Yep. So when we are talking about API, it's pretty important here to mention the semantic versioning, because if you're talking about Magento 1, I believe that there are a lot of guys here who have an experience working with Magento 1. So most of the problem for us as for core developers with Magento 1 was that actually literally everything was an API, because we never use the private accessor level. That's why we use just the protected and public. So, and actually we encourage extension developers and actually third-party developers use the inheritance-based API. So if you would like to introduce new functionality or just override existing one, all you had to do is just inherit from our class and override one of the protected methods, for example. It was pretty typical. But actually, we stuck with the problem at some point of time that because everything is an API, we are not allowed to evolve our code. Because if we add in some changes to our code, we are definitely breaking some of the extension. And actually, we don't know how many extensions we potentially break. So in the Magento 2, we decided to follow the semantic versioning, and as I understand, you know that semantic versioning is like a major update, minor update, and patch updates, and we apply these semantic versioning rules just for the APIs. So you can see in our code base for the interfaces and sometimes for classes, we make a PHP annotation of the API for these entities, which we consider a part of the API. And Magento guarantees that actually these entities are following the semantic versioning. So for example, you could, if you are relying just on the Magento APIs, you can easily upgrade Magento to next patch version, and that would not lead to backward incompatibilities and break in your system. So here we come to pretty interesting concept, public and private code. So those of you who had a background, for example, working on a compiled language like a C++, you're pretty familiar with such stuff that you have a H file, header file, where all the APIs are declared, and the DLL file, which contains the compiled version of your sources. And actually, when you use the DLL, you just include it to your program. For example, if you would like to rely on some functionality which exists in that DLL compiled. But you are not, you don't have an ability to look through the sources to see how some method or class particularly implemented. So the details of implementation is hidden from you, and you don't have an ability to change that. But in PHP, we don't have this possibility on the level of language. But what we decided to do in Magento, we decided to clearly differentiate. So we decided to clearly distinguish. So we decided to clearly distinguish between the public and private code. And actually, the service layer is a part of the public code. And we actually suppose that all the extension developers, that all the third-party developers, all the integrators will rely on the public code, on the entities which are marked with the API, PHP annotation, but not on the code which we consider as a private one. Because taking into account that we are trying to be flexible, and we just want to preserve a possibility for Magento core to make a refactoring. Because continuous refactoring is crucial for the system development, especially such a robust and big as Magento. And we don't really want to get to stuck in a tons of the legacy code. That's why we are proceeding with the continuous refactoring. And to have an ability to proceed with that refactoring, we actually make a differentiation between the public and private code. Yep, and actually here you can see the examples of the public code. So the public code is not just PHP files. It's also the JavaScript. It's also XML configuration. It's also layout, etc., events fired. But currently we are talking about PHP and PHP interfaces. So now we'll talk a little bit. We'll talk. Oh, yeah. So it's pretty interesting because, like, it's not even related directly to Magento. But if you consider how particular interface could be used in your system, you actually find two different ways. That this interface could be used as an API, and it could be used as an SPI. And depending on how it's used, actually the evolution of this interface is changing. And here we will describe and discuss two of these evolutional scenarios. So the first one is an API scenario. So for example, that's actually API when you just get this interface and use it. So for example, there is a product repository. When you add the product repository, inject it to your business logic, and for example, you make some product manipulation, so you like load product by ID or by SKU, make some changes to that product, and after that you are saving product with that product repository. So you're using this interface in an API way. So actually you just rely on it and call the methods out of that contract. And another possible usage of the interface is the SPI, so the service provider interface. So the good example of the service API could be, for example, our search adapter, because we have an adapter interface, and there are different adapters on board. So there are Elasticsearch, Solr, and MySQL. And for example, you as the extension developer, for example, would like to implement own adapter like Sphinx. So all you need to do is to provide the own implementation for that interface. And for example, override the default one with DI configuration provided by Magento. So here, this interface is not supposed to be called directly in a client's code, but that's the interface you are providing implementation for, and just substitute the out-of-the-box implementation. And yeah, and another scenario when actually API and the SPI are like, some of the guys use the interface as SPI, and another guys use interface as an API. So for example, like if we return to the example with the product repository, so one guy could just use product repository to load data, update, and save, but another guy, for example, decide that he would bring some performance update to the product repository. That's why he provides the own implementation, which, for example, saves the data to the Elasticsearch instead. And in this case, the guy who made that kind of improvement and overrides the default implementation actually use the product repository interface as an SPI. And why it matters? Why it matters? Because it matters because after the code is released, both API and SPI could be could be evolved in a backward compatible way, but both of these interfaces have own limitations. And if you'll consider like the API post-release evolution, so in our contract we can freely add new behavior, and we would not break existing business logic we have. So for example, in this example, in phase 1 we have the API with a single public method contract, and for example we had this business logic which just rely on that contract. And after some time, we decided to add a new method, like new contract to this interface. And of course, like in Magento, we provide the default implementation, so we provide the default implementation to this interface. And if you had the logic which look like load that API and call the previous existing contract, you are still okay. So maybe your code is not aware about new API which was added just recently, but we don't break anything. So in API, we can easily add new method, not breaking existing business logic. But we are not allowed to remove anything from the API, and we are not allowed to edit method. So for example, we can just add required parameter, for example, here, because we will break all the extensions we already have which rely on the previous contract. So in API we can add behavior, but we are not allowed neither to update it nor to remove it. And if you're talking about SPI, so here you see the example of the interface with two public methods, and we have a default implementation which provides the implementation for both of this method. So in SPI, we have actually the opposite situation. So we can freely remove something out of the SPI interface, and we would not break existing implementation and functionality. Because, for example, we removed here the contract A method, and you still have the implementation which has both of these methods, contract A, contract B, but you did not break the code. So it still will work. But if you add additional interface, you will definitely break, because the current implementation, the current class which provided implementation for both of that method, is know nothing about newly created method you just added to the interface. So you see that here is actually the table which shows the evolution of post-release evolution strategy for the API and SPI. And you can see here, so it's better not to mix up API and SPI, because if you mix up API and SPI, you can't evolve interface at all after the release, because you will definitely break somebody. Maybe you would break the guy who just use your interface, or maybe you break the guy who just provides the implementation for the interface. And regarding Magento, in Magento we mix up API and SPI, so we don't differentiate API and SPI. So actually, what it literally means, it means that if we release the interface in some release, we are not allowed to change it anymore, because if we change it, we will break some of the extension, some of the code already existing, relying on the contract. And because we don't want to make breaking changes. Actually, we don't want to make breaking changes at all. But we understand, like everybody should understand, that it's a mandatory part. If the system is evolving, we will make at some point of time breaking changes. But breaking changes should be predictable, and we not supposed to introduce breaking changes to the same functionality in several subsequent releases, because that will introduce a lot of additional work for you. That's why actually what we do, we want to have this backward incompatible changes as less as possible and make them predictable. So so who's actually decide what is API and SPI in Magento? Actually, you decide. as the guys who use the Magento code and making integration. Because, for example, if you just use the, for example, like here in the module customer, you rely on the customer repository and you use it just to retrieve the customer and after that update BO, for example, and save it. You can consider that you rely on the customer module using the API. So you can specify just that your dependency on this module is just a major dependency. And you can easily upgrade on both patch and minor versions. But if you provide the own implementation of the, for example, the customer repository, so you are using interfaces declared in a customer module in an SPI way, you're supposed to specify the dependency both on the major plus minor version, because we can and you can freely upgrade your module just in the scope of the patch version upgrades. That's pretty important because doing so, following these rules, you could be safe upgrading Magento to next version. Yeah, and because like I told about predictability, so releasing the big release of Magento, big commercial release like 2.2 or 2.3, we will announce, and we are actually announcing the list of the backward incompatible changes for our public contracts, for our APIs. So here you see, for example, the list of backward incompatible changes for the 2.1 Magento release, and we had the same for 2.2. So now I will show you, now I will show you the list of backward, prohibited code changes we are not allowed to do. And after that, I will show you the ideal design we are currently following and keeping. And you can see that design in an MSI project. So we are not allowed to remove neither interface nor classes. We are not allowed to remove neither public or protected method, and introduce a method to a class and interface is also prohibited. Actually, we had a pretty interesting story. We had a category repository interface, and we didn't have here a get list method because we considered that we have a category hierarchy interface and everything could be done via that interface. But after that, we realized that after we already released the category repository interface, we realized that we don't have enough method for making filtering, like filtering by category name. That's why we decided to introduce that possibility, but we can't introduce it to this interface because we will introduce backward incompatible changes for those who provide their own implementation of this interface. That's why we introduce it as a new interface, which has the only method. And also, we are not allowed to remove the static functional calls. We are not allowed to introduce the parameters to public and protected method. And actually, that's how it's supposed to be. Like kind of refactoring, we allow, for example, if you need to introduce additional parameters. So we are introducing the private method, and it's pretty important here that the old method should call the new one. And because in Magento we are still trying to make the new API to be the only entry.
A veces que la mosca está apuntando a un número y a otro que está.
Yep. So yeah. So the new API should be the only entry point, and if you have because the pluginization, for example, which happens should. Okay. Also, we have a lot of other prohibited code changes.
Voy a ver qué frecuencia es.
Okay, I don't have a lot of time, so to be short, we are limited in most of the possible code changes we would like to do. So actually, we literally not allowed to do anything with the published API code. And like even adding new dependency to constructor, because we have the constructor dependency injection, we need to make pretty sophisticated procedure. We need to add new dependency which we nullify, and in the constructor implementation we we check whether the dependency is null, and if so, we use the object manager get instance method to instantiate the dependency. So it's pretty lot of tricks. Yeah, and many limitations. And actually, like the main rule for us that actually the new code should be backward compatible, and we are ready to live with that code is not look nice, at least at some point of time. So the backward compatibility is the top priority. And yeah, like refactoring that code, we stuck with the problem that that amount of external dependencies started to grow in a classes, because we are not allowed to remove any existing dependency out of the class which will already exist. That's why we start, for example, getting this suppress warning like coupling between objects for many classes we have in the system. But continuous refactoring is crucial for us, and we must do refactoring. So what the solution for us was to answer all that problems, to answer all that high limitation which we have from the backward compatibility point of view. Yeah, so actually that's example how usually backward compatible fix looks like. And you know, it works most of the time, but it's not really usable, and it's not really extendable. Because, for example, if that, for example, tab would be broken in another place, it would be hard to introduce like both fixes simultaneously. So probably one of them could be applied, another not. And actually, yeah, that's true for the code quality as well. And yeah, so solution for us. Yeah. So actually, taking all of the above into account, we came to the conclusion that like good API programming, good service layer programming is basically constructor injection. It's immutable state, single responsibility, and uniform interfaces and value object pass across services. So taking all that into account, we come to a single method immutable objects. And actually, single method immutable object, it's not a new idea. We have a functional programming where actually that idea existed for many years. And actually, there is such entity like functor or functional object. So we are pretty close here. And for example, these interfaces should be introduced currently in Magento. So we use these interfaces on a MSI project. And we introduced just an interface responsible for one particular thing. So here you could see two interfaces. One of them assigns sources to stock. So sources are physical inventories in an MSI project, and we assign them to the virtual stock. And actually, we have just the only interface for doing that. And actually, most of the interfaces in a service layer currently actually has a descriptive name and the method execute. Probably, if you're a PHP developer, you can have a question whether why don't we use the invoke method, like this one. And actually, the answer is pretty simple, because invoke is not a strict typing. So you see that it returns a mixed type and it has a variadic accepted. But actually, you probably know that Magento, starting from the 2.2, is PHP 7+. So we don't support anymore PHP 5.6 and the early version as well. So that's why we actually really want to keep return types and scalar type hinting in our code. That's why we have that execute method with the type hinting and the return types. Yeah. Actually, the only exception currently in our service layer is the repository. And actually, repository got really a lot of popularity among the Magento developers, because repository is pretty popular pattern. And you, for example, if you need to manipulate with some entity, you just make a dependency on a repository, and you can retrieve that entity, update that entity, and save it. So that's actually the only exception out of this rule. So repository usually have this list of methods. And actually, how that example, how not so visible, yeah. Okay, so actually, our repository currently looks like a facade over the commands. So we have commands, like one command responsible for the saving operation, one command responsible for the delete operation, and what a repository does is just proxy that for this particular command. And again, I already showed this slide, so you can see how our current APIs look like. And actually, you can see the example of this APIs currently just in MSI project, because we have this inventory project which started to be developed from the scratch. So we have an ability to make all the changes to the API we would like to make, because making a refactoring to a core code, we are pretty limited, as I already described, because of the backward compatibility. But like in MSI project, if you would like, for example, to see, even if you're not interested particularly in MSI, but if you're interested in a Magento development, you can come to the MSI repo and see how we write code there, what interfaces we create, how we work with UI components, how we make the responsibility segregation. So actually, Magento MSI currently supposed to be used as a sample module as well. So here you see the pretty self-descriptive interfaces. So reading just the name of the interface, like get product quantity in stock interface, you already understand what actually this interface is responsible for. So it's pretty nice as for us, and I hope that you will like it as well. And yeah, the last but not the least, when you are designing good API, don't make your client do anything you can do for them, because actually the main idea of the API is to get rid of the boilerplate code in the business logic. And yeah, and actually at the end of October, PHP Architect released a new issue, and in this issue there are four big articles about Magento architecture. And one of them is actually about the Magento APIs, and this issue is free to download. So if you're interested about modern Magento development and the way how the architecture would be evolving, just download, read. It's pretty interesting reading. And yeah, that's all.